at preparation of standard solution. In our previous lesson, we were able to explain what a standard solution is. We said a standard solution is a solution whose concentration is known, or a standard solution is a solution of known concentration. So for us to prepare a standard solution, we need the following sets of apparatus, okay? So we have the standard volumetric flask, which we say is of different capacity. It can be of 250 ml capacity, it can be 500 ml capacity, it can be 1000 ml capacity, and it can be 2000 ml capacity, depending on the volume of the standard solution you want to prepare. Then we have the chemical balance, which we know what it is used for measuring the mass of the chemical substance, especially solid, that we want to prepare the solution. Then we have the wash bottle. We have the measuring cylinder, which we can use to measure if the chemical that we want to prepare its standard solution is in liquid form. So we use the measuring cylinder to measure the exact amount of the concentrated stock solution that we want to prepare. Then we have 250 ml beaker, which already we know what it is used for. We have the transfer funnel, okay? We have the glass rod, we have the weighing balance, okay? So these are the major apparatus that we need for the preparation of standard solution. So assuming that we want to prepare 0.1 molar sodium hydroxide solution. So what do? First of all, you have to calculate the mass of the sodium hydroxide pellet that you want to dissolve in distilled water. So if I want to prepare 0.1 molar, then the next thing is, after knowing the mass to measure, that is by using the relation N is equals to mass over molar mass. So we have mass over molar mass. So if the molar mass is known, we can go ahead and calculate the mass. But remember, we said our N is equals to concentration times volume divided by 1000. So if we substitute here, so we have concentration times volume divided by 1000 is now going to be equals to mass of the sodium hydroxide pellet we want to prepare divided by molar mass of the chemical. Okay, now C is the concentration, which is the 0.1 molar of the solution that we want to prepare. Then V stands for the volume of our standard solution. Okay, so in this case, assuming we want to prepare our solution to be 1000 ml, maybe due to the number of students who wants to engage in the practicals, so I'll choose 1000 ml capacity of my standard volumetric flask to prepare my standard solution. So what do? You go ahead, you put the concentration into the formula, 0.1 times the volume of solution, which is 1000, okay, divided by 1000, which is equals to the mass I don't know, so which is my unknown. I need to calculate it so that I can use the chemical balance to weigh. The molar mass of sodium hydroxide, if you calculate, sodium is 23 plus oxygen is 16, then hydrogen is 1. So by the time we calculate everything here, so we now say that, okay, our mass, which we are going to measure, is now going to be equals to 0.1 times 1000 divided by 0.1 times 1000 times 23 plus 16 plus 1. Divide everything by 1000. Okay, so by the time you punch your device, you are going to have this as your answer. So which we have 0.1 times 1000 times 23. 0.1 times 1000 will give you 100. So in that case, you have 23 plus 17 will give you 40 plus 100, which is 140. Okay, then 140 divided by 1000 will give us 0.14. So we have 0.14 grams. So this is the mass of sodium hydroxide pellet that you are going to measure to prepare 0.1 molar of this very particular one. So after you do that, you've calculated the mass. The next thing is to transfer the mass to a chemical balance. You measure some of the amount of the sodium hydroxide pellet. Are we together? So the sodium hydroxide pellet, you fetch some amount. So you obtain 0.14 grams on a chemical balance. Okay, so the chemical balance will measure the mass for you. It will read. So using the weighing bottle. So the weighing bottle will definitely be of good help. Okay, so put the pellet little by little, pieces by pieces into the weighing bottle. After, you must have zeroed the balance, neglecting the weight of the weighing bottle, so that you consider the mass of the sodium hydroxide pellet you are adding. Are we together? Because if you cannot take some of the accurate measurement, so it's better you tar the balance to 0 and start adding. That is, after putting the weighing bottle on the balance, you tar the bottom of the balance to read 0, that neglecting the weight of the weighing bottle, so that it will be reading the mass of the pellet you are adding directly. So after you obtain your 0.14 grams on your chemical balance, so what do you do next? You now add little amount of distilled water with the aid of your wash bottle into the weighing bottle. So you rinse a lot, put into the 250 ml beaker, rinse again until no traces of sodium hydroxide pellet are remaining in the weighing bottle. Then dissolve the remaining particles of the pellet that have not dissolved. Are we together? In the beaker using your glass rod by stirring carefully. So by the time everything dissolves, you now transfer the dissolved pellet of the sodium hydroxide using the transfer funnel with the aid of the glass rod, so as to avoid pouring away. Then you rinse the beaker as much as possible with distilled water, and make sure that the standard volumetric flask is filled up to the mark here. So this is the mark. So by the time you are adding, you just have to be very careful so that you don't over pour the solution, and that will exceed the mark here. In this case, which will render your solution to be invalid. So that is that. How to prepare a solid chemical substance in the lab. Not only sodium hydroxide. If you have any chemical substance that is in solid form in the lab and you want to prepare its standard solution, you use this very particular method to do the same, provided the chemical substance have feasible chemical formula. Is that understood?